this video, we're going to continue looking at things that we'll need for composition of function. And really, we have this idea that f minus g is not the same as g minus f most of the time. But when f and g are the same, this is true. We had this idea of f divided by g is not the same as g divided by f. But when they're the same, when f is equal to g, then this is true. So it's natural to ask, when is it that f of g is g of f? Because we saw in our last three examples that it's not true. Not always. And that leads us to this idea of one-to-one. So we're going to put this on the back burner for now. But that's what we're building up to. So, one-to-one is an idea like function. For a function, what we're saying is every x has exactly one y value. So if I have something like this parabola, and I want to think about the parabola at some x value, we have exactly one corresponding y value. So function x goes to exactly 1. Y value. Now, as we can see in this case, there could be multiple x's that go to the same y value, but every x goes to exactly one y. So one-to-one means that between the x and the y, we have exactly 1. Right? For every x, we have exactly one y. And for every y, we have exactly one x. So that means this is not allowed. So if we want to make sure that every x has exactly one y, we normally talk about this vertical line test. If we want to see if something is one-to-one, we want to talk about a horizontal line test. And really, if we want a one-to-one function, we need both of these tests to be passed. We need the vertical line test. Every vertical line only touches the function once. And every horizontal line only touches the function once. So what we'll do is we'll just run through a bunch of examples and see which ones work and which ones don't. F of x equals x. Well, does this pass the vertical line test? Yeah. Every vertical line only touches it once. And every horizontal line only touches it once. So is f of x equal to x one-to-one? Yes. And we normally write that as 1-1, 1-to-1. Sometimes we'll write it out as 1-to-1. But it's the idea that 1x to 1y and vice versa. 1-to-1. 1-to-1. 1. So we've already looked. X squared is a function, but it is not one-to-one because it fails the horizontal line test. And it fails it miserably. It fails it all over the place. Now x cubed we know looks like this. And it passes both the horizontal and vertical line test. Every x value we plug in gets one y value, and it's a unique y value. It's not the same as any of the other x values. All right. So then now we look at the square root of x. And while it may not look like it, it also passes the horizontal and vertical line tests. Because every time I plug in an x value, like 3, this is something different than if I had plugged in 3.1 and 3.2. As these numbers get bigger, the square root of that number gets ever so slightly bigger. So these are all giving me unique y's, y's that are different than the others. Okay. Well, then what about cube root? Well, a cube root is like a square root, but we're allowed to have negative numbers now in our domain. And unlike x squared, we don't have any issues. Really, it's a lot more like x cubed on its side. This looks like a mess, but if you were watching as I was putting those lines, you can see it passes both the horizontal and vertical line test. So far, the only one that didn't pass was x squared. Okay. Now, 1 over x. So we may not have seen these rational functions yet, but 1 over x looks like this. We're not allowed to plug in 0, so that's why nothing is going to touch 0. When I plug in super small numbers, it makes 1 over that number blow up. And then the same kind of things happens with the negative. And we can see here, no issues. This function is also 1-to-1. X squared was still the only one that wasn't. So, as you might guess, 1 over x squared is our only other problematic one. Because again, we don't have this uniqueness. I have 2 x values that are giving me the same y value. So if I'm going to determine whether a function is 1-to-1, I'll want to make sure it's a function, that it passes the vertical line test, or that every x value has exactly 1 y. And then to make sure it's 1-to-1, I want to make sure it passes the horizontal line test. Not only is every x going to exactly 1 y, but I don't want different x's to go to the same y. And the easiest way to look at that is the horizontal line test.